Okay, number 5, we want to find the exact value of tan 15 using half angle identity. Okay, so this one is a bit problematic. Just depends on how you want to solve it. I'll write down the tan 15. So this is what we want to solve. I'm sorry, we can't see what I've written down. Tan 15. There are two ways you can solve it. Okay. There is the formula from the textbook, and then there are the formulas in the Trig cheat sheet. They're both the same, they're just in different formats. So let me show you what I mean. In our Trig cheat sheet, the half angle identity right here. So here's what we have for tangent. It's tan squared, 1 minus cosine 2 theta, 1 plus cosine 2 theta. So I will write this one down and solve it this way. And then in the textbook, I just looked it up online. I went to Trig half angle identity, and the first thing I got was the Wikipedia version. And there are several different forms, okay, that they're all pretty much the same. But what the textbooks show is they show this form. They show tan of 1/2, whatever the angle is. They might put x over 2 or theta over 2. And then you have this version. You have sine 1 plus cosine. You have the 1 plus cosine over sine. And then there are even more that we don't use, but you can just continue to manipulate them. But for simplicity, I'll probably use this one, the sine theta 1 plus cosine. Sine theta 1 plus cosine. So I'll use that one. So there's two different formulas. So we have tan, and I'm going to use x over 2 because that's what you'll see in the text, equals sine of x over 1 plus cosine of x. And then the one from our Trig cheat sheet was tan x. I'm going to put this whole thing in parentheses squared because it's tan squared theta, but this is how we would solve it by hand. And then this is equal to 1 minus cosine of 2x, and then this is equal to 1 minus cosine, 1 plus cosine of 2x. And let me just double check that one more time to make sure that I've written down this correctly. I think they have the plus or minus because when we do the square root, we got to figure out if it's positive or negative. Since it's in quadrant 1, it should be positive. So when we do the square root, we'll continue to have a positive. So let's verify that formula one more time. So we got sine 1 plus cosine, that looks good. And then tan squared 1 minus, and then 1 plus on the bottom. Okay, that looks good. Okay, so in this version, whatever they give you, that is your x. So that's 15. I'll be finding tangent of 15. So I'll find out what that equals. So I'm going to continue working on this side. Tan of 15 equals, or tan of 15 squared equals 1 minus cosine. Now when I do 2 times 15, that's 30. And 30 is a value on the unit circle. That's why they use that formula. This is 1 plus cosine. This is going to be 30 as well, because you do 2 times that x, and x is 15. Okay? And then we have tan of 15 squared equals, okay, cosine of 30 from the unit circle. This is the square root of 3 over 2. So here's where it gets messy. So this is 1 minus square root 3 over 2. And then this is 1 plus square root 3 over 2. So here's where it gets messy. We want to solve for tangent. So notice we have this square. We have to take the square root of both sides. So we have square root this side, square root this side. And so that gives us tan 15, which is what we're looking for, and it equals all of this, which we're going to simplify and reduce this. So we have, what I'm going to do is simplify under the square root, so this is going to be 2 over 2, so I'm going to combine this, so let me just do it one step at a time. 1 is 2 over 2, because 2 divided by 2 is 1, I'm writing it like that so I can combine these fractions, minus square root 3 over 2. Same thing on the bottom, I'm going to rewrite that as 2 over 2, and then plus square root of 3 over 2. So in this case, the formula that we have in the Trig cheat sheet is more messy than the other version. Sometimes this one is more messy. It just depends. So underneath the big square root, we have two fractions. All right, we have 2 minus square root of 3 over 2, and then on the bottom we have 2 plus square root of 3 over 2. Alright, so underneath this, we're going to have a fraction and a fraction. We're going to keep change flipped. So basically what's going to happen, the 2's are going to divide out the bottom term, and we'll be left with this. So I have square root of 2 minus square root of 3, and then I have 2 plus square root of 3. Alright, what we want to do now is, I guess I could write these as their own separate square root. So think about this as all of this under a square root. So I'm going to get rid of the big one. Okay, so when you have a fraction under square root, it means a square root on the top and a square root on the bottom. Okay, so that's what I want to think about that. Alright, so there's 2 terms under the square root, but I want to get rid of the outer square root, the big square root first. So in order to rationalize the denominator, I have to multiply it by this whole square root term. So square root of 2 plus square root of 3. I'm going to do that. I'm running out of room, so I'm going to have to pick up on another sheet. So continuing with that process, this is what I have. I have the square root of 2 minus, and then it's still under the square root of 3. And then on the bottom I have square root of 2 plus square root of 3. Okay, so I want to get rid of the outer square root. So I have to rationalize the denominator by multiplying by that exact expression. So I'm going to multiply by square root of 2 plus square root of 3 on top and bottom. Square root of 2 plus square root of 3. Alright, when you multiply something times itself, it gets squared and the outer square root is gone. So on the bottom, we're just going to have 2 plus square root of 3. Because this times this is basically this term squared. And when you square, you get rid of the square root, so you just have what's left underneath it. Now, both these terms being under the square root, we can FOIL and multiply them together. So what you see here is the difference of squares. You see 2 minus square root of 3, 2 plus square root of 3. So when I multiply these two terms together, the square root doesn't go away, but I do get to apply that difference of squares formula. So what I get is this, a plus b times a minus b. That gives us a squared minus b squared. So all I have to do is square this and square this. So if you square 2, that gives you a 4, still under the square root. And if you square the square root of 3, that gives you a 3. Okay, the square root goes away. Alright, so simplifying this, 4 minus 3 is 1, and the square root of 1 is 1. So that square root pretty much goes away anyway. So 4 minus 3, 1, square root of 1 is 1. On the bottom, we have 2 plus square root of 3. Okay, so now when you rationalize a binomial, because I still have a square root on the bottom, I got to get rid of that. You multiply by that conjugate term, so what we call the complex conjugate, which is 2 minus the square root of 3. You have to do this because if you try to multiply by square root of 3, it would get rid of this, but you would have to distribute, and you would have another square root of 3 down here. So you have to do this term on top and bottom. 2 minus the square root of 3. Alright, so again, on the bottom, what happens, this is the difference of squares. You square this term and you square that term. So we're going to have 4 minus 3. That's exactly the same thing we had there. When I multiply times 1, I just get this term, 2 minus square root of 3. When we subtract this, that gives us 1. So I just have 2 minus square root of 3 divided by 1, which just gives us 2 minus the square root of 3. Okay, so that is a mess, but that's what we get, 2 minus the square root of 3. Now, here is the book form, and hopefully it won't take us nearly as long. But the x over 2 is equal to 15, okay, what they gave us from the beginning. So I have to figure out what is x equal to. So compare this, x over 2, and this. Those two are equal. So x divided by 2 is equal to 15. You solve for x by multiplying by 2 on both sides. So times 2 times 2. That goes away. We get x is equal to 30. So we still end up with that 30 scenario. So what we have here is tan of 30 divided by 2. That's how we got our 15. That's how that equals 15. So that's the same thing there. And then this is equal to sine of 30 over 1 plus cosine of 30. Okay, so the difference here, when you first start out, this one, they give you 15, you can just plug it in, and then you solve from there. It gets messy. Here, you have to solve up front and figure out what x is. Once you get that, then it becomes a lot nicer. So here, tan 30 divided by 2, that's tan of 15. And then sine of 30 from the unit circle gives us 1/2. And then on the bottom, 1 plus cosine of 30, 1 plus cosine of 30 is the square root of 3 over 2. Okay, so we're going to combine. We're going to keep, change, flip when we do that. So 1/2 on the top. On the bottom, change this to 2 over 2 and add. So I'll have a 2 plus square root of 3 over 2. Then when we keep, change, flip, this becomes 1/2, change, flip. This becomes 2 over 2 plus square root of 3. The 2's will divide out, and then that gives us 1 over 2 plus square root of 3. And then from here we just have to rationalize the denominator. So that is 1 over 2 plus square root of 3. You have to multiply by the conjugate, which would be 2 minus square root of 3 on top and bottom. And then complex conjugate on the bottom, we square, so we have 4 minus 3 when we do that, and then we have 2 minus square root of 3. So 4 minus 3 is 1, so just basically we get the top 2 minus the square root of 3. Is that what we got over here? Yes, 2 minus the square root of 3. So you can see, you get the same thing, but you do have to know the solving process. I believe I did this in class, but I didn't do that square and rationalize the denominator correctly. But our final answer is 2 minus the square root of 3. 2 minus